Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am taking spectroscopy, and this is lecture number 3 in this case. Now, in previous lecture I explained you how to get internal structure or information about internal structure of any molecule. For that we need to irritate molecule. We have to give energy to the molecule, and the only source of energy is light. So once the light is given to molecule, then and then we get a molecule in excited state, and it will give us some informations. What is light? Light is EMR, electromagnetic radiations, and these are different fractions of cosmic EMR. Light is basically EMR, and this will function according to Einstein's formula E is equal to h nu and E is equal to hc upon lambda. And if you go from different fractions from cosmic to radio waves, and you can see that wavelength increases, so energy decreases according to this formula, and frequency also decreases. If energy decreases, frequency decreases. If you go from cosmic rays to visible, here you can see that energy decreases, so that frequency decreases but wavelength increases. And this is the trend throughout. Like even in if you go from IR microwave to radio wave, the same pattern is observed, that here you go from left to right, then energy decreases, frequency decreases, but wavelength increases. That means radio wave has minimum energy and maximum wavelength, while cosmic rays are having maximum energy and minimum wavelength. All these different fractions have different kind of effect on molecule. So cosmic is having maximum energy, and normally this will penetrate through the molecule or atom, and therefore it cannot affect internal structure of atom. Now, what is the effect of gamma rays on the structure of atom? So gamma rays will penetrate orbits and will strike nucleus, and it can emit protons or neutrons or from this nucleus, and that will produce nuclear reaction. So basically this will rearrange here by when atom or molecule absorb gamma rays, there will be rearrangement of nuclear particle takes place, nucleons takes place. Okay, and having energy about 10 raised to 9 to 10 raised to 11 joule per gram atom, and it is known as nuclear reaction. So gamma rays are mainly involved in carrying nuclear reactions of a given molecule. X-rays. What is the effect of X-ray? Let us see this one. Here, suppose this is a molecule and there are more than one atoms in molecule like this. So here, these are different internal orbits of atoms, and electron move from internal orbits of one atom to another atom. Okay, so this is basically electronic excitation but in inner cell. And that is why it can bring the change in internal structure, and so that we get some informations about internal structure. The most useful region for us is ultraviolet to visible. Okay. Now, what is the basic change appear because of the absorption of ultraviolet visible radiations by a molecule? Let us see this one. This is a molecule which is having at least two atoms. This is internal orbit, and it can have sigma bond and as well as pi bond. Okay. So this is sigma bond, this is pi bond. Electrons are in this orbital. We call it bonding molecular orbital. And if you know that every molecule has empty in anti-bonding orbitals also. So if there is a pi bond in molecule, there will be pi star ABMO orbital, which is empty in fact. But the moment molecule absorb UV radiations, then electrons from pi orbital transit to pi star orbital. This is excited electron. Okay. So this is called pi to pi star transition. Pi to pi star transition. Okay. So here we consider this as electronic excitation of electrons or electronic excitation from BMO to ABMO. And this is due to translational motion of electron. Okay. So this is due to translational motion of electron. Now we'll see what is the effect of infrared on molecule. Okay. Suppose molecule is polar, having different types of atoms with certain angle, and if this molecule absorb infrared, then these atoms start vibrating in different directions. Okay. So this can be stretch or bend. So stretching and bending of molecule takes place, which is called basically vibrations. So infrared, when molecule absorb infrared, normally molecule vibrate. So this will bring change in vibrational motions, and that is the main effect of infrared. Now we will see what is the effect of microwave. When molecule is having two atoms of different weight, that means center of gravity will be something towards one of these heavy element. This is center of gravity. And when molecule absorb microwave, then these molecules start rotating around this center of gravity. So this is basically bring change in rotations of molecule. Okay. So microwave will produce rotations in molecules, infrared produce vibrations in molecule, and ultraviolet visible produce translational motions of the electrons. Radio waves. which is having minimum energy, and it can change. Precession of molecule, of nucleus rather. Okay, so this is also known as nuclear magnetic resonance, NMR, that we'll discuss later on. But these are different fractions of, in this lecture I am explaining you that there are various fractions of light from cosmic to radio waves. Energy decreases, wavelength increases, frequency decreases. And different fractions of EMR, that is light, has different effect on molecule. Okay, so gamma rays can change nucleus, X-ray can change internal orbits, UV visible produce electronic translation motion of electrons from BMO matlab bonding molecular orbital to anti-bonding molecular orbital. Infrared produce vibrations of a molecule, particularly polar molecules, and microwave gives rotations to the molecule. So this way, different radiations have different effect on this molecule. Okay, so this is the main idea behind producing different kind of effect on molecule. Okay, now we will see what happens when this molecule absorb these radiations. So when molecule absorb specific EMR, electromagnetic radiation, for the change in orientation and therefore the intensity of radiation also changes. The absorbed radiations are scattered or reflected when pass through the matter. Radiations are emitted at the same wavelength or at different wavelength. If not, then the orientation of molecule, the orientation of waves changes. Or polarization occur, means some kind of effect appear in the molecule because of absorption of certain amount of radiations, and these changes are recorded by detector in the form of signals known as spectra. And if we can interpret these signals, we get certain informations about molecules, and this is called spectroscopy. Thank you so much.